Welcome. In this video, we're going to look at factoring polynomials with four terms. So when we have four terms in our polynomial, we're still going to start by looking for your greatest common factor of all of your terms. And then we're going to use what's called grouping. So we're still going to be doing greatest common factor, but we're going to look at groups of our factors because if we have four terms, we can make two groups of two. Unlike when we have three terms, we can't make pairs. So still going to look overall greatest common factor. In this case, our greatest common factor is 1. Once we've checked for a greatest common factor for the whole thing, we're going to pair off our terms and look for greatest common factors in pairs. So just these two here have a greatest common factor of 2, right? 2 goes into 6 and 8. And then b squared, right? We have b, and b. They both have two factors of b in common. And then divide that out just like we've done before. And so 6 divided by 2 is 3. B squared divided by b cubed divided by b squared is b. 8 divided by 2 is 4. And then my b's are all gone. Okay. And then we're going to look at our second factors. So remember, we're still adding this together. And look for our greatest common factor there. So in this case, 9, b, and 12, our greatest common factor is 3. 3 goes into 9 3 times with that b left over, and 3 goes into 12 4 times. So when you're factoring by grouping, really what you're looking for here is now, do these factors that we've pulled out, do those factors match each other? So now we're looking at this as if this is two terms, which it really is, and our common factors here are actually these binomials, that this binomial here that I'm multiplying by matches this one as well. So I can factor out that whole binomial and say these both have a 3b plus 4. And now I'm left with this guy, 2b squared plus this guy. Right? So we end up with our thing here. And if we work our way backwards, we should end up back where we started. So if you're ever not sure with your factoring, multiply back out and see if you get back to where you started with. Also, a great thing to check is once we're here, can we factor further? So 3b and 4, we're looking for greatest common factor, or the only other binomial we can factor further is if it's a difference of squares. So we don't have common factors, we don't have a difference of squares. So that is our factored form. Okay, let's try another one. So 4 terms, greatest common factor are still the first thing we're going to start with. Once we've checked that, then we're going to group. So group, and then we're really just doing greatest common factor. So greatest common factor here is x squared, left with x plus 2, plus greatest common factor here is 8. We're left with x plus 2. And really we want that x plus 2 to match up, so that's a good sign. Because now both of these things are being multiplied by x plus 2. So that is a factor of both of them. I can factor that out, and I'm left with x squared plus 8. Can't factor further, all done. Okay, let's keep going. So greatest common factor, 6, 4, 12, 8. Ooh, we can pull out a 2. So we're going to pull out that 2 first and say I have 3y to the 4th minus 2y cubed plus 6y minus 4. Okay, looks like we got our greatest common factor because now those don't have a common factor. So now this 2 is just going to come along with us. It's still a factor of the whole thing. So now I'm looking at my pairs for my greatest common factor. These two have a y cubed in common, and I'm left with 3y minus 2. These two have a 2 in common, and we're left with 3y minus 2. This whole thing is still being multiplied by 2. Okay, now I'm looking at these two terms. They both have a 3y minus 2, and we're left with y cubed plus 2. Check to make sure if I can factor either of those further and bring that greatest common factor along with us. We're all done. Okay, greatest common factor, 5, 15, 1, and 3, nothing there. Oh, but they do all have a factor of y. So I'm going to factor out that y first. 5y to the 3rd minus 15y squared plus y minus 3. Once we've done our greatest common factor, that factor of y is just going to come along. It's still a factor of the whole thing. And then we're looking at our pairs here. So greatest common factor here is 5y squared. And then we're left with y minus 3. This doesn't look like it has a greatest common factor, but I still want to factor something out. This already matches that. So we're going to factor out a 1 just so I can see that that factor's there. Because now it's easier to see that they have this y minus 3 in common. And then my leftovers here are my 5y squared plus 1 once I divide out that y minus 3. So we're going to pull that y minus 3 out front, just like we pulled all of our greatest common factors out front. And then we're left with 5y squared plus 1. Don't forget this factor of y that we pulled out at the very beginning. Okay, if you're feeling pretty good about this, this would be a great time to pause, try them on your own, and come back and check. Okay, greatest common factor here of all. No greatest common factor, so we're just going to group right off the bat. Okay, these two have a 2x squared in common, and I'm left with x minus 6. Okay, I want this to end up looking like this, so I'm going to rewrite this as negative 3x plus 18, just so it's easier for me to see. And if I pull out a 3, I'm going to be left with negative x plus 6, but I want it to be x minus 6, so I'm going to be a little smarter about what I pull out. I'm going to take out a negative 3, and then I'll be left with x minus 6, so I can see that those factors here match. So now my common factor is x minus 6, and when we pull that out, we're left with 2x squared minus 3. So might have to do a little manipulating there. Be careful with your positives and negatives. If it looks really close, but you're getting the wrong signs, think about pulling out a negative. Okay, so next one, greatest common factor, none. Group, okay, greatest common factor of just these two, 5x squared, and then I'm left with 3 minus 2x. Okay, greatest common factor here is 4. But now I have 2x minus 3. So those don't quite match up. I want my x's to be negative. So that's where I'm going to go back and say, oh, I pulled out almost the right thing, but my signs are backwards. So we're going to change this here to a negative 4. And then that will make this negative 2x plus 3. Negative 2x plus 3 and 3 minus 2x are the same. If you don't like that, rewrite it so they look the same. Those are equivalent. Okay, now these two things both have a factor of 3 minus 2x. If you want the other way, that's totally fine. And 5x squared minus 4. Okay, 2 more examples here. A little straighter. Okay. 4 terms. So we're looking greatest common factor overall. Doesn't look like we have one. Okay, so let's group. Okay, these two have 4x in common. And we're left with x squared plus 6. Okay, if we want this to match up with that, I'm just going to take out a negative 1 to get x squared plus 6 as well. These both have an x squared plus 6 factor, and I'm left with 4x minus 1. Okay, so even though these are scrambled up, it still works to group. Could you have written it in standard form and then grouped? Definitely, you'll still get to the same 2 factors. Okay, last one, greatest common factor. Ooh, they do have one. 3x goes into all of those. So we're going to take that out first. 2x cubed minus x squared minus 8x plus 4. Once we've taken our greatest common factor, remember that factor is just going to be a part of our solution all along. It's being multiplied by whatever I have here. So I'm going to have that 3x times whatever I have here. So my greatest common factor here is x squared. I'm left with 2x minus 1. Greatest common factor here, again, I want it to look like this. So I'm tempted to pull out just a 4, but then I have negative 2x plus 1. And I want 2x minus 1, so I'm going to pull out a negative 4 and get that 2x minus 1. Okay, now both of these terms have a 2x minus 1. So I can factor that out, and I'm left with x squared minus 4. Ooh, this is a first. Hopefully we notice something about this x squared minus 4. We haven't had this yet, that binomial is factorable. Right? This is a difference of squares. So we can factor that part further. So my 3x is going to stay there. My 2x minus 1 is going to stay there. X squared minus 4 factors to, what did I square to get x? Plus, what did I square to get 4? Times, what did I square to get x? Minus, what did I square to get 4? So make sure you are always checking, can I factor further? With a binomial, you only have two options. You're either looking at greatest common factor, which hopefully you've already taken care of way back at the beginning, or this difference of squares, which factors to what did you square to get the first thing, plus what did you square to get the second thing, what did you square to get the first thing, minus what did you square to get the second thing. Okay, so that is all I have for you today. Thanks so much for watching.